Picture yourself standing somewhere far from any city, in the soft dark of a southern night, with the air cool against your skin and the whole sky tilted open above you. Low toward the horizon, where the land goes quiet and blue, there is a star that does not look like much at first. It is steady. It is warm white, with the faintest amber breath inside it, like the last ember of a fire seen through gauze. You could pass it 1,000 times and never guess what it holds. And yet the light touching your eyes right now left that point of sky more than 4 years ago, travelling all that while through the cold between the stars, only to arrive at this exact moment, only to find you looking up. That light has crossed something close to 40 trillion kilometres to reach the back of your eye, and it asks nothing of you in return. What you're seeing is not one star at all. It is a small family of suns, bound together by gravity, leaning on one another across the dark. 2 of them shine close and bright, so close in our sky that the unaided eye cannot pull them apart, and a third drifts far out in the shadows, too dim to see without a telescope, yet nearer to us than any other star in the entire heavens. This is Alpha Centauri, the closest stellar system to our own, the doorstep of the galaxy, the very next house down a road so long that light itself takes years to walk it. You do not need to hold any of this. You do not need to remember a single number or name. Let your mind go loose and easy, the way a hand opens when sleep begins to come. Let the facts move through you like slow water over smooth stones. Some will stay, most will drift on. What remains in the morning will be exactly what was meant to remain, and nothing here is a task. There is only the soft turning of the sky, and your breath, and the gentle weight of your own body settling deeper into the quiet. So let the eye return to that warm point near the horizon, and look closer in the mind. The brighter of its 2 visible stars is named Rigil Kentaurus, an old phrase meaning the foot of the centaur, for this light sits low in the constellation Centaurus, the great star figure of a creature half man and half horse, galloping forever through the southern sky. To the people who first named it, that single point marked where the centaur's hoof pressed down against the edge of the world. And here is the first quiet wonder of it. That foremost star, Alpha Centauri A, is very nearly a twin of our own Sun. It is a yellow star of the same kind, only a touch larger and a little brighter, carrying close to 1 1/10 the mass of our daytime star and pouring out about 1.5 times its light. If you could stand on a world beneath it, the morning would feel almost familiar. The colour of noon would be a shade you already know. Of all the billions of stars scattered through the galaxy, the nearest one of all turns out to be a near match for the star that warms your own sky, as though the cosmos had set a mirror just beyond reach. Beside it, leaning close in that same patch of light, is its companion, Alpha Centauri B. This one is smaller and cooler, an orange star carrying around 9/10 the Sun's mass, and shining with roughly half its brightness. Its colour, if your eye could separate it from its brilliant neighbour, would be the warm amber of late afternoon, the gold that pools in a room just before dusk. The 2 of them are not strangers passing in the night. They are bound, circling one another in a slow, gravitational embrace that has lasted for billions of years, 2 suns held in a single quiet dance. Now let the gaze widen and soften, out past those 2 bright partners, into the dark around them. There, far from the pair, far enough that it takes more than 2 full degrees of sky to find it, drifts the 3rd member of the family. It is a red dwarf, small and dim and deeply red, and its name is Proxima Centauri. The word Proxima means nearest, and the name is earned, for of all the stars in all the sky, this faint red coal is the one closest to us. It is our true next-door neighbour in space, and still it lies so far away that its light spends 4.25 years crossing the void to reach us. There is something tender in that arrangement. The most brilliant member of the family is the one we can see, and the nearest member is the one we cannot. Proxima glows too faintly for any human eye to catch on its own. You could stare straight at the empty-looking dark where it floats and never know a sun was there, the closest sun beyond our own, hidden in plain view, waiting patiently in the cold. And these three are not scattered by accident. Together they form a single bound system, a triple star, three suns holding to one another across the immense distances between them, all of them sharing one slow journey through the galaxy. When astronomers measure the motion of the bright pair and the motion of the distant red dwarf, the numbers agree. They are travelling together, they are kin. So the nearest star to Earth is not a lonely point, but a small companionship of suns, two leaning close near the horizon, one set far out in the dark, all three bound to one another and travelling the same long road through the galaxy. The very word at the front of its name carries a quiet meaning. Long ago, when astronomers began labelling the brightest stars in each constellation with the letters of the Greek alphabet, the most brilliant in any figure was given the first letter, Alpha, and so this light, the foremost glory of the Centaur, became Alpha Centauri, the chief star of its sky creature. The name is older than any knowledge of what it truly was. Centuries before anyone could guess at red dwarfs or measure the gulf between suns, someone simply looked up, saw which star shone brightest in that great southern figure, and crowned it with the first letter of all. The name has held ever since, a small inheritance of wonder handed down from watchers who knew far less than we do and felt every bit as much. The figure that holds it is one of the grander shapes in all the heavens. Centaurus sprawls across a wide swathe of the southern sky, a sweeping pattern of stars long imagined as a centaur, that gentle creature of old story, the wise and kindly half-horse who was said to have taught the healing arts and the reading of the stars themselves. There is a fittingness in that the nearest of all suns should be set into the form of the very teacher who first guided human eyes among the constellations. The brightest point of that wise figure is also the closest doorway to the rest of the galaxy, as though the old teacher were quietly pointing the way. And though the two bright suns blur into one for the naked eye, the smallest of telescopes parts them with ease. Through even a modest spyglass, that single warm point splits cleanly into two separate stars, one golden, one faintly amber, sitting close together like a pair of lamps in a far window. It is among the lovelier sights the southern sky offers to a small telescope. The moment the one becomes two, the moment a single star is revealed as a quiet partnership, anyone with the simplest of instruments and a clear view to the south can witness it, can watch the nearest sunlight divide into the pair of suns it has always been. That paired light is prized by stargazers for the soft contrast of its colours. When the two suns come into focus side by side, the difference between them shows gently, the foremost a warm yellow-white, its companion a tender shade of orange-gold, the two hues sitting close together like a candle flame beside a deeper ember. It is a quiet, painterly sight, this pairing of warm tones, one of the gentlest pleasures the telescope can offer. To see the nearest star resolved into its two-coloured suns is to glimpse the simple beauty of difference held close, two lights of slightly different warmth keeping company in the same small field of view. To witness any of this, though, you must seek out a truly dark sky, far from the glow of cities. Beneath the washed-out skies of bright towns, even the brilliant pointing stars lose much of their splendour, and the fainter wonders vanish entirely into the haze of artificial light. But step out into real darkness, into the deep country night where the stars come out in their thousands, and the southern sky opens like a held breath, the nearest suns burning clear and steady low toward the horizon. The wonders of the night reward the patient and the dark-adapted eye, asking only that you leave the glare behind and let the true sky reveal itself. What truly sets this system apart, though, is not its brightness, but its nearness, and that nearness can be measured by a beautifully simple trick. As the Earth swings around our own sun across the year, the very closest stars appear to shift their positions ever so slightly against the more distant background. The way a near object seems to jump from side to side when you look past it with one eye and then the other. The closer the star, the larger that yearly wobble. Alpha Centauri shows one of the largest such shifts of any star in the sky, and from the size of that tiny sway, astronomers can read its distance with great precision. Its very nearness writes itself into the heavens as a small annual dance, a gentle to and fro against the deeper dark, and from that delicate motion we learn just how close our nearest neighbour truly stands. And the size of that yearly sway is, by the measures of the sky, the largest any star can show. Across the whole year, Alpha Centauri shifts back and forth against the far stars by an angle of only about 3/4 of a single arc second, a slice of sky so fine that 3,600 of them would fit across the width of 1 degree, and a degree itself is but twice the width of the full moon. To shift by so slight an amount is for a star to lurch wildly. No other sun in all the heavens swings so far. That tiniest of wobbles, far too small for any eye to catch, is the very thing that betrays this system as the closest of all, its nearness written in a motion narrower than the width of a coin seen from kilometres away. Think, too, of the long quiet voyage each ray of that light has made. A single particle of light, leaving the surface of one of those distant suns, crosses the entire gulf between the stars at the greatest speed nature allows, and still it travels for years on end through the empty cold before it finally meets your eye. It passes no signpost, feels no friction, knows no rest, simply streaming onward through the dark at the limit of all speed, year after year, until its journey ends in the soft landing of your gaze. Every glimmer of starlight you have ever seen is the close of such a voyage, a traveller arriving at last after years in the void, and the light of the nearest star is among the very shortest of those long, long journeys. And starlight is, in truth, among the oldest things your unaided eyes can ever take in. Even from the nearest sun, the light you receive set out years ago, older than this morning, older than last season, having waited out its long crossing while the world turned beneath it. To look up at the night, then, is to gaze upon nothing that is truly present, but only upon arrivals, old light finally completing its passage. The sky is a gallery of the past, hung with the patient light of distant fires, and the nearest of those fires offers the freshest portrait there, a glimpse of only a few years gone, the most recent of all the heaven's old letters. Consider too how that warm light ranks among all the lights of the night. To the eye, the combined glow of the two bright stars of Alpha Centauri is the third brightest starlight in the whole of Earth's sky, brighter than nearly every star you could ever name, outshone only by Sirius, the diamond of winter, and by Canopus, the great southern beacon. Yet most people who have ever lived never saw it, simply because it hangs in the southern half of the heavens, hidden below the horizon for everyone who lives too far to the north. It is at once one of the most luminous and one of the least famous of all the bright stars, a treasure kept for the lower half of the world, and even taken singly, pulled apart from its partner, the foremost sun alone holds a high place among the lights of the night. Counted on its own, Alpha Centauri A ranks as the fourth brightest individual star in all of Earth's sky, trailing only Sirius and Canopus and the golden glow of Arcturus, and outshining every other star a watcher could name. So whether you blur the pair into one bright point or split them cleanly into two, the nearest sunlight stands among the small handful of brightest stars there are, a yellow beacon low in the south that would draw any eye lucky enough to lie beneath it. For those who do live beneath it, the star is a faithful companion of the dark. From the far southern latitudes, Alpha Centauri never sets at all. It circles the southern pole of the sky in a slow nightly wheel, always above the land, never sinking, a fixed and steady presence that has guided travellers and sailors and shepherds for as long as people have looked up and wondered. It is the kind of star you could grow up beneath and come to think of as a friend, and it has long served as a signpost as well. Alpha Centauri and its bright neighbour Beta Centauri together are known as the Pointers, two brilliant stars set close in the sky whose line, when followed across the dark, leads the eye straight to the Southern Cross, the small luminous cross that marks the deep south of the heavens. For countless generations, sailors crossing unfamiliar seas have used these two pointing stars to find that cross, and from the cross, the direction of south itself. So the nearest star to our sun has spent untold centuries doing a humble and beautiful work, simply helping the lost to find their way home through the night. The little cross they point toward is itself a jewel of the southern sky, and the very smallest of all the constellations. Tucked into a bright patch of the Milky Way, the Southern Cross is so compact and so distinct that it has become the emblem of the southern half of the world, woven into flags and songs and the dreams of sailors. And the two pointing stars stand close beside it like faithful guardians, forever indicating the way to that small bright figure. The nearest sun keeps watch beside one of the most beloved patterns in all the heavens, a steady companion to the little cross that has come to mean the south itself. There is a gentle constancy in the work these stars perform. Night after night, age after age, the pointing stars have hung in the same relation to the cross, never failing those who knew to read them, an unmoving map drawn in light across the southern dark. No instrument was needed, no chart, only the knowledge of where to look and the patience to look there. The nearest star has been, through all the long centuries of sail, a quiet keeper of direction, a fixed and faithful guide in a turning sky, asking nothing and giving the precious gift of knowing which way is home. There is a kind of peace in that thought, that something so vast and distant has also been so close to the everyday hopes of people standing on a dark shore, watching for two stars to point the way south. The nearest sun to ours has spent uncounted centuries as a faithful southern signpost, guiding lost travellers safely on their way. The brighter star's old name was made official only recently. For most of history, the title Rigil Kentaurus lived informally, passed along in star charts and sailors' lore without any single body to bless it. Then, only a handful of years ago, the keepers of astronomical names gathered the loose threads of tradition and formally set that ancient phrase as the proper name of Alpha Centauri A, and the name Toliman as the proper name of its companion. So a word for the centaur's foot that had drifted down the centuries from desert and shore was at last, quietly, written into the official register of the stars. The oldest names and the newest decisions met, and the foot of the centaur kept the name it had carried all along. The brightness of the pair taken together is striking even by number. Combined into a single point as the eye sees them, the two suns shine at a magnitude brighter than every individual star save two, a glow that would command attention in any sky lucky enough to hold it. Even the foremost star alone, separated out, ranks among the most brilliant handful of stars anywhere, its light rivaling the great beacons that have anchored human navigation since the beginning. Whether you count them as one or as two, these are among the most luminous points the heavens offer, and they happen to be the very closest of all. There is a quiet lesson, though, hidden beside Alpha Centauri in the sky. Its bright partner in pointing, Beta Centauri, sits close beside it to the eye, the two of them seeming a matched pair of neighbours, yet they are nothing of the kind. While Alpha Centauri rests only a few light years away, Beta Centauri blazes from hundreds of light years off, a vastly more distant and far more powerful star that merely happens to fall along nearly the same line of sight. The two appear as twins, and are in truth separated by an immense gulf, one a near and modest neighbour, the other a remote giant. It is a gentle reminder that the sky flattens everything onto a single dome, that two lights side by side may be unthinkably far apart, and that nearness, out there, is almost never what it seems. For all its brilliance, this system stays hidden from much of the world. Because it rides so far south among the stars, Alpha Centauri never climbs above the horizon for anyone living much beyond the lower latitudes of the northern half of the planet. Across all of the far north, through the great cities and long winters of the upper world, The nearest star to the Sun simply never rises, never shows itself, remains forever below the edge of the sky. Whole civilizations have lived and dreamed and named their stars without ever once seeing the closest sun of all. It belongs, by an accident of geometry, to the southern half of the Earth, a secret kept from half the human family. And to the peoples of the far south, this light has belonged for a very long time indeed. The first inhabitants of the southern lands wove these bright stars into their oldest stories, watching them wheel above the desert and the sea, marking seasons and journeys by their rising and setting long before any telescope was dreamed of. The same two pointing stars that later guided sailing ships were already woven into songs and ceremonies tens of thousands of years old. The nearest sun has been a companion to human imagination across the whole long reach of memory, holding its place in the oldest sky stories on Earth, a faithful light low in the southern dark. Now let the mind drift inward, to the two bright suns themselves, and to the slow dance they keep. Alpha Centauri A and B do not stand still beside one another. They orbit a shared centre of gravity, swinging through a long and patient ellipse that takes very nearly 80 years to complete, an orbit almost exactly the span of a long human life. A child born when the two stars are closest together could grow old and grey, and see them swing apart and come back around again, just once in a single lifetime. The dance is slow because the distances are so large and the bond, though strong, is unhurried, the way the deepest and oldest things in nature tend to be. Their closeness is not fixed through that long swing. At the nearest point of their orbit, the two stars come within about 11 times the distance from Earth to the Sun, roughly the span between our Sun and Saturn. At the farthest point, they drift apart to around 35 times that distance, close to the gap between our Sun and distant Pluto. So across each 80-year turning, the pair breathe in and out, drawing near as if to whisper, then easing back into the wide quiet, then drawing near once more. If you could watch from a world circling one of them, the other sun would grow and shrink in your sky across the decades, never close enough to scorch, never far enough to vanish, a second light always there. Out beyond them, the third star keeps an orbit so vast it nearly defies the imagination. Proxima Centauri is thought to circle the bright inner pair at a distance of something like 13,000 times, the span from Earth to the Sun, drifting through the outer dark on a path so enormous that a single loop may take more than 500,000 years to complete. One orbit of that little red star is longer than the entire span of our own species. When the last of those orbits closed, there were no cities, no written words, no farms, only scattered bands of early humans under the same indifferent stars. Proxima moves, but at a pace measured against the lifetime of mankind, not the lifetime of a person. In our sky, that distance shows itself as a small gap of separation. The faint red dwarf sits a little aside from the bright pair, removed by a couple of degrees of sky, about 4 times the width of the full moon held against the heavens. It seems a slight remove, a mere hand's breadth, and yet across the true depth of space it amounts to that staggering gulf of thousands upon thousands of times the Earth's distance from the Sun. The little star drifts in the outskirts of its own family, near enough to belong, far enough to be almost alone, a quiet sentinel posted out at the edge of the system's wide, dark estate. Should you stand within that system, on a world circling Proxima itself, the bright pair would be your distant sky's most striking feature, but they would not warm you at all. So far off would they be, even from there, that they would give no more heat than a brilliant pair of stars, lovely to behold but cold, while your own small red sun did all the gentle work of warming. The two bright suns would be ornaments of the heavens to a Proxima world, dazzling and remote, near in the family yet far beyond reach, a reminder that even kin among the stars keep distances too great for warmth to cross. That vast, unhurried motion can be its own kind of comfort. Out there, nothing is rushing. The great wheel turns once in 500,000 years and is in no hurry at all. There is nothing for you to keep up with, Nothing to chase, no clock that matters in the spaces between the stars. Let your shoulders loosen, let the jaw unclench, let the breath grow long and unforced. The closeness of the two bright suns shapes where worlds may safely live. Because A and B swing so near to one another, the space directly between them is restless, tugged this way and that by two competing gravities, no calm place for a planet to settle. Yet each star can still hold worlds of its own, drawn in close, orbiting near enough that the partner sun feels like a distant second light rather than a rival. A planet circling Alpha Centauri A would keep snug to its own star, and B would hang in its sky as a brilliant point, near and far at once. The architecture of such a system is its own delicate art, a careful sorting of where stability may hold and where it may not, and nature, given billions of years, has had ample time to find the quiet places. These suns most likely began together, born from a single cloud. The bright pair almost certainly condensed side by side out of one collapsing knot of gas and dust, twin embers kindled from the same dark cradle, and have kept one another's company ever since. The little red dwarf at the edge may have formed in that same nursery, or may have drifted in later and been gently caught, and astronomers still turn the question over with care. But whether siblings from birth or a foundling taken in, the three now move as one, bound for the long ages ahead. There is something warm in either story, in suns that grew up together and never parted, or in a small lost star that found, at last, a family to belong to. The two bright suns are not far in size from our own. The foremost is a little larger across than the sun, a touch wider and grander, while its orange companion is somewhat smaller, more compact, a slightly lesser sphere of fire. Set the three side by side, our sun and these two, and they would look like near relations, three middling stars of modest and familiar scale, none of them the bloated giants or the pinprick dwarfs that crowd other corners of the galaxy. The very nearest bright stars to us are reassuringly ordinary in their dimensions, suns much like the one we know, neither monstrous nor minute, simply steady and middle-sized and kind. These three suns are old as well, older than the ground beneath you would suggest, for they have been shining for something like 5 to 6 billion years, an age close to that of our own sun. They were already ancient when the first single-celled life stirred in Earth's young oceans, already old when the dinosaurs walked, still burning steadily as the human story flickered into being and began to keep its records. To look at Alpha Centauri is to look at light from a furnace that has been quietly lit since long before the Earth knew what it was to be warm, and the stuff they are made of carries its own faint signature of history. The two bright stars are richer in heavy elements than our sun, seasoned with more of the metals and minerals that are forged inside earlier generations of stars and scattered when those stars die. A higher share of such elements means these suns were born from gas, already enriched by the ash of older stars, the recycled remains of suns that lived and ended long before. Every star is built from the dust of the ones that came before it, and Alpha Centauri wears that inheritance a little more thickly than our own. There is a long, unbroken lineage written into its light, a quiet reminder that nothing in the cosmos is truly new, and nothing is ever truly wasted. That richness in heavy elements may be a gift to any worlds the system holds. The very same metals and minerals that season these stars are the raw materials from which rocky planets are built, the stone and iron of solid worlds like our own. A star generous in such elements was born from a cloud well stocked to make planets, the cradle already laden with the makings of solid ground. So the abundance written into these suns is not only a mark of their ancestry, but a promise of fertile beginnings, the kind of enriched birthplace where worlds of rock and metal can readily take shape. The nearest stars were born into plenty, and plenty is what worlds are made from. It humbles the mind to set the long life of these suns against the brief flicker of our own histories. By the time the first humans looked up and wondered at the stars, Alpha Centauri had already been burning for billions of years, unchanged and unhurried. The whole sweep of human memory, every empire and every story ever told, fits into the smallest sliver at the very end of these stars long shining. They were ancient before we began, and will go on long after, indifferent and serene. There is a strange peace in that vastness of time, a sense that one may safely set down the weight of any single day beneath the patient gaze of such enduring fires. Now turn the picture gently around, and imagine standing not here, but there, on some imagined world within that distant system, looking back the way the light has come. From Alpha Centauri, our own sun would not be the centre of anything. It would be only a star, a single bright point among the thousands. But it would be a fine one, a clear white star of about the brightness of the brightest stars in our own night, easily seen, easily admired by anyone over there who happened to look up. And it would not stand alone in their sky. From that vantage, our sun would appear set within the familiar W shape of the constellation we call Cassiopeia, adding one more brilliant point to that zigzag of stars, turning the well-known queen of our sky into a slightly different and richer figure. Somewhere, in principle, an observer beneath Alpha Centauri could glance up, find that bright addition to Cassiopeia, and be looking, without knowing it, straight at the small warm star that holds you now. And here is the loveliest part of that imagined view. Apart from the new bright point of our sun, the rest of their night sky would look almost exactly like ours. The distance between us and Alpha Centauri, vast as it is for travel, is so small against the great depths of the galaxy that nearly all the other stars would hold their familiar places, the same constellations wheeling overhead, the same great patterns we have always known. The hunter, the swan, the seven sisters, all would shine there much as they shine here. Two skies, separated by trillions of kilometres and yet nearly identical, sharing all the same distant stars, differing only by the single addition of our own modest sun. The cosmos is so deep that even our nearest neighbour shares almost the whole of our view. There is a quiet kinship in that shared sky. Should any eyes ever look up from a world of Alpha Centauri, they would gaze upon the very same constellations that have guided and comforted us since the beginning, the same patterns our ancestors named, the same lights we still find tonight. We would be neighbours not only in space but in scenery, two households beneath nearly the same painted dome of stars. The night sky, it turns out, is wide enough to be shared, a common ceiling spread over the nearest worlds, the same old lights looking down on us all. Within that shared sky, our own sun would shine for them as a notably bright star, the most brilliant point in the small zigzag of Cassiopeia, lending that familiar figure an extra glow it does not wear for us. Our daytime star, so commanding here, would there be only one fine light among many, lovely but unremarkable, a single bright addition to a well-known shape. There is a gentle humbling in that thought, that the sun which rules our every day would, seen from the nearest doorstep, be merely a pretty star in someone else's constellation, a quiet point in the patterned dark, no grander than the lights we name and forget. And the view runs both ways. The sun's light reaches Alpha Centauri, and Alpha Centauri's light reaches Earth, two faint points of warmth trading places across the same unimaginable dark, each one a bright star in the other's sky. The exact distances within this neighbourhood are known to a fine degree. The little red dwarf, being slightly nearer than its bright siblings, sits just over 4¼ light years from us, while the bright pair rests a touch farther, a little past 4⅓. The difference between them is small against such a span, a mere fraction of the whole, the width of the system itself laid sideways to our line of sight. To measure such distances at all, to pin them down to within a hair across 40 trillion kilometres and more, is one of the quiet triumphs of patient observation. We know how far our nearest neighbours stand to a precision that would astonish the watchers of even a century ago. To feel that distance in the language of our own machines, consider how far we have actually reached. The fastest spacecraft ever launched, the long-lived probes flung out past the planets decades ago, have travelled steadily for nearly half a century and have only just crossed beyond the influence of our own sun into true interstellar space. and in all that time, at all that speed, they have covered only the smallest sliver of the way to Alpha Centauri, a distance so slight against the whole that, if the journey were a long road, those probes would have walked barely the first few steps. The nearest star is near only to light. To everything slower, it remains almost unimaginably far. There is a boundary, too, that marks where our own sun's reach finally ends. Far out past the planets, the steady wind of particles streaming from our sun thins and slows until it can push no farther against the gentle pressure of the space between the stars, and there it stops, forming a vast invisible bubble around our entire solar system. Beyond that edge lies true interstellar space, the open country between the suns, through which the light of Alpha Centauri has travelled for years to reach us. Our nearest neighbour lies well outside our sun's bubble, across that quiet frontier, in the wider dark where the stars hold their own separate dominions. To cross to it is to leave one sun's country entirely and journey through the open between. And the title of nearest star is not a permanent one. As the stars drift along their separate paths through the galaxy, the question of which sun sits closest to ours slowly changes across the ages. Alpha Centauri holds the honour now, and will for a long while yet, but in the deep past other stars have worn that crown, and in the deep future others will take it up. The nearest neighbour is a role that passes slowly from star to star across hundreds of thousands of years, a gentle changing of the guard in the quiet dark. For this long moment in cosmic time, the moment that holds your whole life and every life you have known, it is Alpha Centauri that keeps the closest watch, and that is a kind of privilege, to live in the age when this particular family of suns is the nearest of all. That distant family is not standing still relative to us. The whole Alpha Centauri system is drifting through the galaxy along its own path, and at this moment in cosmic time, that path is bringing it slowly closer to our sun. It draws nearer at a little over 20 kilometers each second, which sounds swift until you remember how far it has to come. Even at that pace, it will take many thousands of years for the gap to meaningfully shrink, and the change will be far too gradual for any single generation to notice. The stars do move. They simply move on a clock so vast that to us, the night sky seems eternally fixed. That approach, though, does have a quiet destination. Far in the future, some 26 to 28,000 years from now, the Alpha Centauri system will reach its closest pass to our own, drawing in to a little under 3 light-years away before beginning, ever so slowly to drift back out again. For a long stretch of time around that distant date, the nearest star to Earth will be nearer than it has been in all of recorded history. The gulf between us narrowed to its smallest. No one alive today will see it. The world that will look up at that closest star is as far ahead of us as the last ice age is behind us. And still, knowing the appointment is set that the sky is quietly keeping it, lends the dark a kind of patient steadiness, the sense of a slow promise being kept across the ages. Even at that nearest pass, though, the gap will remain immense and the meeting entirely peaceful. The system will still hold itself well clear of us, separated by trillions upon trillions of kilometers, close only by the most generous reckoning of the stars. There is no collision in its future, no disturbance of our own quiet corner, only a slow, gentle approach and an equally slow withdrawal, the two systems passing like distant ships that never come within hailing. The drifting of the nearest stars is the very soul of gentleness, a movement so slight and so safe that it brings nothing but a slow change in the depth of the dark between us. And in that long future age when the system has crept into its closest, it will shine in the sky a little brighter than it does tonight, the nearest suns grown subtly more brilliant as they draw near. The people of that distant time will look up at a slightly grander pointing star, a touch more luminous than the one we know, though they may never guess it is so. The sky is always quietly shifting, always slowly rearranging its lights, and the nearest stars take their own small part in that endless gentle change, brightening by degrees across the millennia toward their moment of closest approach. Within that drifting family, the small red star at its edge holds wonders of its own. Proxima Centauri burns far cooler than our Sun, its surface glowing at only around 3,000 degrees on the absolute scale, little more than half the temperature of our own star's face. That coolness is why it shines so red, the deep ember colour of metal that has only just begun to glow, the colour of the very last light in a fading coal. It is a sun, fully a sun, fusing the same fuel in its heart as our daytime star, and yet it would feel less like blazing fire and more like the steady warmth of embers banked for the night. It is also a small thing as suns go. Proxima carries only about an eighth of our sun's mass, and its body spans little more than the width of the planet Jupiter, scarcely larger than a great gas giant rather than a star. Imagine that, a true sun, a furnace of fusion, no wider than the largest planet in our own family of worlds. It is among the more modest lights in the galaxy, and yet within that small frame it does everything a star does, holding planets, pouring out warmth, fusing the elements in its core. Size out among the stars is not the same as significance, and though it is faint and small, Proxima is far from quiet. It is what astronomers call a flare star, a sun given to sudden dramatic outbursts. Without warning, magnetic energy stored in its surface can release all at once, and the little red star can leap in brightness, flaring far brighter than its usual gentle glow before settling back to calm. One such eruption, recorded not long ago, was a superflare so powerful it briefly multiplied the star's visible light many times over, one of the strongest stellar flares ever witnessed from so near a star. The smallest sun in our neighbourhood is also one of the most temperamental, a tiny ember that now and then throws sparks. For all that liveliness, the little star turns upon itself with great slowness. Where our own sun spins round about once a month, Proxima takes far longer to complete a single rotation, wheeling slowly on its axis over the better part of 3 months. A day there, one full turn, would stretch on and on by our reckoning, an unhurried rolling of the small red sphere through the dark. Its magnetism, though, runs deep and strong for so modest a star, knotting and tangling beneath the surface until it snaps loose in those bright flares. There is a curious gentleness even in its restlessness, a slow turning paired with sudden sparks, the patient and the fierce held together in one small ember of a sun. The flares themselves come often, a frequent quiet drama for so small a star. Several times a year, the little red dwarf looses one of its great outbursts, and smaller flickers ripple across its surface far more often still, so that the star is rarely entirely at peace. To an eye that could watch it closely, Proxima would be a living, restless thing, brightening and settling, sparking and calming, never quite the same from one hour to the next. The faintest nearby sun is, by this measure, among the most animated of all, a small fire forever shifting its light, a quiet show playing on and on in the dark with no audience at all. Strangely, for all its smallness, this dim star can blaze fiercely in kinds of light the eye cannot see. In the high, energetic glow that our instruments detect but our eyes cannot, Proxima can shine surprisingly bright, especially during its flares, rivaling for a moment the output of far larger suns. The little ember holds a hidden fierceness, a hot magnetic temper tucked inside its modest red body. It is a reminder that the gentlest looking things may carry unexpected fire within, and that a star need not be large to be lively. Even the smallest sun given a tangled magnetic heart can flare with a brilliance beyond its size. It is worth remembering that these flares are simply weather, the natural moods of a living star, not violence aimed at anything. Every star has its storms, its surface unrest, its sudden brightenings and slow calms, the way our own sun throws its flares and spots without malice or aim. Proxima's outbursts are only the ordinary breathing of a magnetic star, more frequent and more dramatic for its kind, but no stranger in nature than the changing weather of a sky. To watch them from a safe and distant remove is simply to watch a small sun being itself, restless and radiant by turns, a far-off fire flickering in the cold. And the total warmth that this small star pours out is astonishingly slight. Where our sun floods space with its great steady blaze, Proxima radiates only the tiniest fraction of that light, less than 1,000th part, a glow so faint that across the gulf to us it vanishes entirely from the naked eye. It is a sun that whispers rather than shouts, husbanding its light, spending it slowly and sparingly across the eons. That very faintness is bound up with its endless life, for a star that gives so little can sustain itself so long. The dimmest fires, out among the stars, are very often the most lasting. Even so, there is a deep gentleness in how Proxima lives out its long life. Because it is so small and burns its fuel so slowly and so frugally, it is fated to last almost beyond comprehension. While larger stars race through their lives and die in a few billion years, this little red dwarf will go on shining steadily for something like 4 trillion years, a span hundreds of times longer than the present age of the entire universe. The smallest, dimmest stars are the most patient of all, and Proxima will still be glowing softly long after our own sun has lived its whole life and gone dark. There is a reason for that astonishing endurance, and it lies in the way the little star stirs itself. Proxima is thought to churn all the way through, its entire body slowly circulating like a pot of warm liquid kept gently turning, carrying fuel from its outer layers down into its burning core. Our own sun cannot do this. It keeps its layers more separate and so can only ever burn the hydrogen near its centre. But Proxima mixes everything it has, sip by sip, drawing on nearly its whole supply of fuel over the eons. It is the most thorough and frugal of furnaces, wasting almost nothing, drawing its single great breath of fuel out across spans of time so long that whole cosmic ages pass before it has spent even the first measure, and that thrift is the secret of its near-eternal life. That patient red star does not burn alone in empty space. Around Proxima Centauri, worlds have been found, real planets circling the nearest sun beyond our own. The first and most famous of them is called Proxima b, a world close in mass to our own Earth, only a touch heavier, a rocky planet rather than a ball of gas. And it lies within what astronomers call the habitable zone, the band of distances from a star where the warmth is neither too fierce nor too faint, where, in principle, liquid water might gather and rest on a solid surface. The nearest planet to Earth that orbits another sun is, by that measure, the right distance to be temperate. It is a quiet and remarkable thing to know that just next door, around the closest star, there waits an Earth-sized world in the gentle middle ground of its sun's warmth. That world keeps very close company with its star. Proxima b circles its little sun at only about a 20th of the distance from Earth to our own, sweeping all the way around in a mere 11 days. A year there, one full orbit, passes faster than a single fortnight here. But because the star is so cool and so dim, that nearness does not mean fire. At that snug distance from a small red ember, the warmth can still be mild. The planet huddles close simply because that is where the gentle heat of such a faint sun is found. It is a reminder that closeness and comfort are not the same near a small star as they would be near a large one, that each sun shapes its own circle of warmth in its own particular way. The way that world was found is a small marvel of patience. No telescopes or the planet itself. Instead, astronomers watched the star for years and noticed it swaying ever so slightly, drawn into a tiny rhythmic wobble by the gentle gravity of something circling it. From that faint stellar sway, a movement of only a few footsteps' pace, they deduced the presence of an unseen world and weighed its mass and traced its orbit. The careful campaign that confirmed it was given a tender name, the search for the pale red dot, a quiet nod to that famous portrait of our own pale blue Earth seen from afar. To find a world you cannot see, by the barely perceptible tug it gives its star, is one of the most delicate feats in all of science, and it was first achieved in full for the planet next door. Stand on that world in the mind and picture the sky above it. The little red sun would loom large there, far larger than our sun looks from Earth. A great ruddy disk filling a wide patch of the heavens, glowing not white gold but deep rose and crimson, casting a soft red daylight across the land. And in that same sky, by day and by night alike, two more brilliant stars would burn, the distant pair of bright suns, A and B, shining so fiercely from their faraway perch that they would outshine everything else in the heavens, a pair of dazzling points that no darkness could ever fully hide. To live beneath Proxima B's sky would be to live always in red light, under a vast crimson sun, with two brilliant companion stars forever keeping watch from the deep beyond. Imagine the look of a landscape washed in that deep red light, hour upon hour. The hills and plains would wear shades we glimpse only at our own day's end. The long red of sunset stretched across an entire world and held there, unmoving. Shadows would fall soft and rose-tinged. The very air might glow a dusky crimson, and what we call the colours of evening would simply be the colours of every moment. It is a strangely soothing scene to picture, a whole world bathed in the gentle red of a sun that never climbs and never sets, the perpetual hush of a planet held in everlasting warm-toned light. No one may ever stand there, and yet there is a real joy in simply knowing such a place may exist, just next door, around the nearest star. The closest planet beyond Earth could be a world of rose-red daylight and stars that never move, its rust-coloured hills lit by a sun the deep shade of a banked fire, and watched over by two far brilliant points of white, real, and turning in the dark whether or not any eye ever sees it. A second world has been confirmed there as well, and it is a marvel of smallness. Proxima d is a tiny planet, carrying only around a quarter of the Earth's mass, one of the very lightest worlds ever discovered around any star. It hugs its sun even more closely than the first, sweeping around in only about 5 days, a small companion riding a tight and rapid inner loop. To detect a world so slight, so far away, by the faint tug it gives its star, is a feat that borders on the impossible, and yet there it is, confirmed. A delicate little world orbiting the nearest sun. The galaxy, it turns out, is furnished not only with giants, but with the smallest and most fragile of worlds, and we are only just beginning to find them. That tiny world's confirmation came only very recently, after years of patient watching. The first faint hint of it was glimpsed, then doubted, then gradually pinned down as the instruments grew finer and the measurements longer, until at last it could be spoken of as real. So even now, in our own time, the nearest star is still revealing its hidden worlds to us. One careful confirmation at a time, the family next door slowly coming into focus across the years. There is a freshness to that, a sense of standing at the very edge of discovery, where the closest sun is only now showing us all that it holds. The band of warmth around so small a star is a narrow and delicate ribbon. Because Proxima gives off so little heat, the zone where a planet could be gently temperate lies very close in, a slim circle hugging the star, where a world must orbit in mere days to catch the right measure of warmth. Stray a little too far, and the faint heat fails into frost. Press a little too near, and it tips toward too much. The habitable ribbon of a red dwarf is a fine and slender thing, a tightrope of mild temperature drawn close around a small fire. And the nearest planet to Earth that circles another sun walks very near that ribbon, poised in the gentle middle ground of its dim sun's warmth. For all its closeness to its star, the world called Proxima b may bathe in an amount of light not so unlike what Earth receives from the sun. Though it huddles many times nearer to its little ember than we sit to our own great star, that ember gives off so much less that the warmth arriving at the planet's surface can fall into a familiar range. It is a gentle balancing, the nearness offsetting the faintness, so that a world pressed close to a dim red sun might still know a mild and temperate light. The arithmetic of warmth, out among the stars, has many ways of arriving at the same gentle sum. When astronomers work the numbers more closely, they find that Proxima b likely catches something near 2/3 of the sunlight that Earth receives, a measure of warmth not so far from our own. A world drinking that much light from its small red sun could, in the right circumstances, hold liquid water somewhere on its face, neither boiled away nor frozen solid. And because the little star throws its frequent flares, the upper air of such a planet might shimmer often with aurora, great curtains of coloured light rippling across its skies far more often than the rare northern lights of Earth. A world perhaps painted again and again in slow green and crimson glows above its rust-red ground. There may be a third world there as well, though this one remains uncertain, hovering at the edge of what can be confirmed. Astronomers have seen hints of a larger planet, Proxima c, circling much farther out on a slow, wide orbit of several years, a possible super-Earth or small ice world waiting in the cold outer reaches of the system. Whether it is truly there, and exactly what it is, the careful instruments have not yet fully settled. So there remains a small open question hanging in the dark around the nearest star, a world half glimpsed, neither quite found nor quite ruled out, a gentle mystery still being patiently unravelled. And there is a loveliness in a question left open, still unsettled at the edges, still waiting. Not everything in that distant system has to be resolved. A world half glimpsed in the cold outer reaches, neither quite found nor quite ruled out, is its own small wonder, a mystery being unravelled across the years with great care and no hurry at all. Now lift the attention back to the two bright suns, for they too may hold a hidden world. Around Alpha Centauri A, the sun-like star, astronomers using a great space telescope have caught a faint and intriguing signal, a possible giant planet drifting in the warmth, somewhere between the sizes of Saturn and Jupiter, circling its star at roughly twice the distance from Earth to the Sun. If it proves real, it would be the closest such giant world ever directly glimpsed, a vast gas planet orbiting the nearest sun-like star to our own. The signal is still being checked and watched, for catching the dim glow of a planet beside the dazzling glare of its star is one of the hardest things astronomy attempts. But the very possibility is wondrous, that just there, in the closest sunlit system to ours, a great ringed giant of a world might be turning slowly in the cold. Imagine such a world, if it is there. A pale gas giant, bitterly cold at around 50 degrees below zero in our familiar reckoning, hanging in the soft light of a star much like our sun, perhaps wrapped in storms and bands of cloud, perhaps cradling moons of its own. It would be a near twin in setting to the great planets we know, only orbiting a different sun, the nearest stranger sun in all the sky. To think that the closest sun-like star to Earth might keep a giant world of its own is to feel the galaxy grow suddenly more familiar, more furnished, more like home. To even glimpse such a thing demands extraordinary patience and cunning. The glare of the star utterly drowns the faint warmth of any planet beside it, the way a single bright lamp can blind you to a candle held close behind it. So astronomers use special masks within the telescope to block the brilliant starlight itself, hiding the dazzling sun behind a tiny shield so that the dim glow of anything nearby can finally creep into view. And they watch in the infrared, the warm invisible light that a cold planet still quietly radiates of its own. Only by these careful tricks, blocking the star and listening for the faint heat of a world, could so subtle a signal ever be caught at all. The candidate at the nearest sun-like star is a whisper at the very edge of what our finest instruments can hear. Whether the whisper proves a true planet, only time and further watching will tell. A signal so faint, drawn from beside so fierce a star, must be checked and rechecked, observed again and again, before anyone can speak of it with certainty. New and greater telescopes, some still being built, may one day settle it for good, confirming the giant or showing it to be only a trick of light. For now, it hangs in that lovely state between a possible world at the nearest doorstep, neither proven nor dismissed, and there is no impatience needed here, no rush to know. The slow, careful unfolding of such a question is itself a quiet pleasure, a mystery being tended with great gentleness across the years. Hold that image a moment, a great cold planet turning in distant starlight, far out where there is no edge to fall from, no height, no danger, only open space and worlds moving through it without a sound. Your body grows heavier against the bed now. The thoughts come slower. That is exactly as it should be. The nearness of all this has stirred a very old human dream, the dream of actually going. Because Alpha Centauri is the closest star system of all, it has become the natural first target for any imagined voyage beyond our own sun, the obvious first port of call should we ever learn to sail between the stars. One ambitious project has even sketched a way it might begin, not with great crude ships, but with tiny featherweight probes, no heavier than a postage stamp, pushed up to a fraction of the speed of light by an enormous beam of laser light shone from Earth. Such a probe, if it could be built, might cross the Gulf to Alpha Centauri in only a couple of decades, rather than the many thousands of years that any ordinary spacecraft would need. That particular dream even has a name, sketched out a few years ago and called Breakthrough Starshot. In its design, a great field of lasers spread across the ground would join their light into a single beam of staggering power, focused for just a few minutes upon a tiny silicon chip trailing a mirror-bright sail only a few paces wide. In those few minutes of pushing, the little craft would be driven to nearly a fifth of the speed of light, faster than anything human hands have ever made move, swift enough to cover in 20 years a distance our real probes would need 70,000 years to cross. It remains a sketch on paper, unbuilt and perhaps far off, yet it is a real and careful plan, aimed squarely at the nearest of the suns burning low above the southern horizon. Sit with the scale of that for a moment, gently. With the rockets we have today, the chemical engines that carry our machines to the planets, a journey to even the nearest star would take tens of thousands of years, far longer than all of recorded history. The closest star to Earth is so far that our fastest real spacecraft, hurled outward with everything we can presently muster, would still need a span of time longer than civilization itself to arrive. That is what a single light year truly means, written in the language of travel rather than the language of light, and Alpha Centauri lies more than 4 of them away, and yet that distance, vast as it is the smallest such distance there is. There is no closer star, no nearer sun, nothing between us and Alpha Centauri but empty space. If we ever do reach out and touch another star, it will almost certainly be this one, this warm point low in the southern sky, this small family of suns leaning together in the dark. It stands at the very threshold of everything beyond, the first step on a staircase that climbs all the way to the far side of the galaxy and beyond. The closest door is still impossibly far, and somehow that makes the wanting of it only sweeter. Even sending a simple word across that gap would test all patience. A radio signal, travelling at the very speed of light, would still need more than 4 years to carry a single greeting to Alpha Centauri, and more than 4 years again to bring any answer back. A question and its reply would span the better part of a decade. There could be no conversation, no quick exchange, only messages sent like letters into a vast slow ocean, each one drifting for years before it ever arrived. Across that distance, even light, the swiftest messenger there is, becomes a thing of long waiting. To speak to the nearest star would be to learn a patience deeper than any we practice here. Being the very closest, this family of suns has long drawn our listening as well as our dreaming. When astronomers turn their great dishes outward, hoping to catch any faint whisper of a signal from the wider cosmos, Alpha Centauri is among the first stars they point toward, the natural place to begin, simply because it lies so near. So far the listening has heard only the natural murmur of the stars themselves, the hiss and crackle of ordinary cosmic sound. Yet the impulse to lean toward the nearest light and listen is a gentle and very human one, the same impulse that draws us to a knock at the nearest door, the quiet hope that we might not be alone. And the very technique that revealed the planets next door has, in our own time, uncovered worlds beyond counting all across the galaxy. By watching for the faint wobble of a star, or the slight dimming as a planet crosses its face, astronomers have now found thousands upon thousands of worlds circling other suns, turning the once empty galaxy into a place teeming with planets. The discovery of the planets at Proxima was one small part of that great unveiling, the nearest example of a truth now seen everywhere, that worlds are not rare at all but common as the stars. We have learned, within a single lifetime, that the sky is full of worlds, and that some of the very nearest are among them. The worlds of Proxima were teased out of the dark by careful machines beneath the clear desert skies of Chile. There, on a high and arid mountaintop where the air is still and dry and the nights are among the darkest on Earth, sensitive instruments bound to large telescopes measured the faint rhythmic sway of the little red star night after night, year upon year, until the gentle tug of unseen worlds could be read from its motion. The first, Proxima b, was announced about a decade ago. The tiny inner world, Proxima d, was confirmed only a few years back as the measurements grew finer still. So the nearest planets beyond our own were found not by seeing them at all, but by listening, with great patience, to the small wavering of a distant ember above the mountains of the south. And should a tiny probe ever make the crossing, its visit would be the briefest of glimpses. Moving at a great fraction of the speed of light, such a featherweight craft could not slow itself at journey's end. It would simply hurtle through the Alpha Centauri system in a matter of hours, snapping what images it could as it flew, and then race on into the dark beyond. After a journey of decades, the close encounter would last less than a single afternoon, a fleeting hello at enormous speed, the gathered light of years of travel spent in a few precious hours of seeing, and then, even those images would take more than 4 years to make their long way home to us. Everything about reaching the nearest star is wrapped in this strange arithmetic of long waits and brief arrivals. Other dreamers have imagined slower, grander ways of going, vast vessels that would carry travellers across the gulf over many human lifetimes, whole communities born and living and dying aboard a single ship, so that distant descendants might be the ones to arrive. Such a voyage would take not decades but centuries, the destination reached only by the great-great-grandchildren of those who first set out. The nearest star is far enough that even our boldest imaginings of crossing it stretch across generations, turning a journey into an inheritance passed down through an unbroken line of lives. To touch Alpha Centauri may be a thing no single person could ever do alone, but only a people, together, across time. The cleverest of the swift proposals would lean on nothing but light itself for its power. A gossamer sail, thinner than a soap bubble and broad enough to catch a mighty beam, would be pushed from behind by a concentrated shaft of laser light shone from the ground, the gentle pressure of that light building, over a few brief minutes, to a tremendous speed. There is a poetry in the idea that light, the very thing the stars send to us, might also be the thing that bears a craft toward them, a beam from home pressing a tiny sail outward across the dark. The same touch of starlight that warms a face by day could, in principle, drive a featherweight probe to the nearest sun. For now these remain dreams sketched on paper, beautiful and unbuilt, waiting on inventions not yet made. And there is no sorrow in that, no urgency at all. The nearest star will keep its place, patient and unhurried, for as long as anyone could need. Whether we reach it in a century or 1,000 years or never at all, it will go on shining there low above the southern horizon, the closest of all the unreached lights, a standing invitation that asks for nothing and waits without end. The dream of going is itself a gentle pleasure, needing no fulfillment to bring its quiet joy. For all the longing to reach it, the nearest sun was slow even to be noticed for what it is. The bright pair had been named and steered by for thousands of years, and still the faint red member at the system's edge stayed hidden, too dim for any eye, waiting at the very threshold of the dark to be found at all. Even the closest star took some finding. The faint red dwarf at the system's edge, Proxima itself, was not recognised until a little over a century ago, picked out in the year 1915 by an astronomer working under the clear southern skies of Johannesburg. He noticed that this dim red point shared the same slow motion across the sky as the bright Alpha Centauri pair, drifting in step with them, and so realised it belonged to the same family and lay just a little nearer to us than they did. The closest of all stars, our very nearest neighbour in the cosmos, went unknown to science until well within the memory of living families. It had been there all along, faint and patient, simply waiting to be seen. And seeing it at all is no small feat, for Proxima is so dim that no human eye can ever catch it unaided. Its light, by the time it reaches us, is many times too faint for the unassisted eye to register, lost utterly in the blackness between the brighter stars. Only through a telescope of decent size does it finally appear, a small red spark against the dark. There is a strange poetry in that. The single nearest star beyond our sun, the closest other furnace in all of space, is completely invisible to us as we stand and look up. The nearest is the hidden one. Sometimes the things closest to us are exactly the things we cannot see without help, and learning to look is its own quiet art. The three suns of this family each belong to a different class, a different rung on the great ladder of stars. Astronomers sort all the suns of the galaxy by their colour and warmth, from the searing blue-white giants down through the steady yellow stars to the cool, faint reds, each given a letter to mark its kind. The foremost here is a yellow sun like our own. Its companion is an orange star a step cooler, and the distant dwarf is a red star, far down at the gentle end of the ladder. In this one small system, three of those rungs are gathered together, a yellow, an orange and a red, a tidy sampling of the long spectrum of stars all bound into a single household. To know the nearest family is to meet, in miniature, the whole graceful range of what suns can be. A star's colour is simply the signature of its heat. The hottest suns burn blue and white, their fierce surfaces blazing at tens of thousands of degrees. The cooler ones glow yellow, then orange, then deep red as their warmth declines, each shade an honest report of the temperature beneath. So when you look at these three lights and see gold and amber and crimson, you are reading their fevers directly. The yellow sun the warmest, the orange one milder, the little red dwarf coolest of all. Colour, out among the stars, is never mere decoration. It is the truth of the fire, written in light, legible to anyone who learns the simple grammar of it. There is more still hidden in that light, for a star's glow carries the secret of what it is made of. When astronomers spread starlight out into its rainbow of colours and look closely, they find fine dark lines threading through it, each line the fingerprint of a particular element burning in the star: hydrogen, iron, calcium, and the rest, each absorbing its own precise hue. By reading those lines, they can name the very ingredients of a star they will never touch, learning the recipe of a sun across light years of empty space. It is in exactly this way that we know these distant suns to be a little richer in heavy elements than our own. The whole composition of the nearest stars is written into their light, waiting to be read by anyone patient enough to look. That same patient reading of a light may, before very long, tell us something of the worlds themselves. Astronomers dream of telescopes able to catch the faint glow of a planet like Proxima b directly, to spread its slender light into colours and search there for the telltale fingerprints of air and water, the soft signatures of an atmosphere, perhaps even of life. Some imagine vast shades flown in space to blot out the glare of the star, freeing the planet's whisper of light to be studied on its own. The tools are not yet built, but the path is clear, and the nearest worlds are the most likely first subjects of that gentle scrutiny. We may yet read the very skies of the planets next door. For now, though, so much remains tenderly unknown. Whether any of these nearby worlds holds water or air or oceans or any spark of life, no one can yet say. The questions hang open in the dark, waiting on instruments and years still to come, and there is no impatience needed in the waiting. The nearest worlds will keep their secrets a while longer, and the slow unveiling of them is a pleasure to be savoured rather than rushed. It is a fine thing to live in an age when such questions can at last be asked, even if the answers are still drifting somewhere out ahead just beyond our reach. Let the eye rest now on the brighter pair once more, and on their gentler, more familiar nature. Alpha Centauri A, that near twin of our Sun, is a yellow star of almost the same temperament, its surface glowing at a warmth close to our own stars, pouring out a steady golden light that an earthly eye would find ordinary and kind. Were you somehow standing in its glow, the day would not look alien. The light would fall the colour of our own afternoons. Among all the wildly varied suns of the galaxy, the blistering blue giants, and the swollen red monsters and the faint cold dwarfs, the very nearest bright star is reassuringly beautifully average, a sun much like the one you have known all your life. Its orange companion, Alpha Centauri B, carries the proper name Toliman, an old word thought to come from an Arabic phrase for the ostriches, the southern stars once imagined as those long-legged birds. So the two bright suns each carry an ancient human name, Rigil Kentaurus and Toliman, the foot of the centaur and the ostriches, names given long before anyone knew these were separate suns, before anyone dreamed they were the nearest stars of all. People looked up and felt the need to name that light, and so they did, weaving it into their stories of beasts and birds and heroes. The same point of light that we now know as a triple sun was, for our ancestors, simply a fixed and faithful star worth the giving of a name. There is comfort in that long human company with the stars. For as far back as memory and record reach, people have stood beneath these same lights and felt moved to call them something, to make them part of the family of named and known things. The light has not changed, only our understanding has deepened. And beneath it all, the simple act remains the same as it was for the first watchers by the first fires, to look up into the dark and to feel, somehow, a little less alone. You are part of that long line tonight, lying here, your eyes growing heavy, the ancient stars wheeling slowly overhead. Let the mind turn now to the very idea of distance out here, and to the gentle measuring stick that astronomers use. A light year is not a measure of time at all, despite the sound of it, but a measure of length, the enormous distance that light, the fastest thing there is, travels in one full year. Light crosses the span from the sun to the earth in only about 8 minutes, yet to cross even a single light year, it must travel without pause for an entire year, day and night, season after season. And Alpha Centauri lies more than 4 such light years away. The number is small, as cosmic numbers go, almost intimate, and still it hides a distance so vast that the swiftest thing in all of nature needs more than 4 years to cross it. That same distance carries a quiet message about time. Because the light you see from Alpha Centauri has spent over 4 years in flight, you're never seeing the system as it is now, but only as it was when that light set out. You're looking, always, a little way into the past. If something were to change in those distant suns this very night, no eye on Earth could know of it for years to come. To gaze at the stars is to gaze backward in time, to see the cosmos not as it is but as it was, each point of light a small message sent long ago and only now arriving. The whole night sky is a kind of memory, glowing softly overhead, and the very nearness of Alpha Centauri makes its message one of the freshest in all the sky. Most stars you can see are tens, hundreds, even thousands of light years away, their light departing in ages long past, some of it leaving before there were cities or writing or wheels. But the light of Alpha Centauri is only 4 years old when it reaches you, news of the recent past practically current by the standards of the heavens. Of all the ancient letters the stars are forever sending us, this one from the nearest sun is among the most lately written, the most nearly now. It is the closest thing the night sky has to a message sent today. Hold that span of 4 years against the small measures of a life, and it grows strangely intimate. The light arriving from the nearest star tonight set out about as long ago as a young child has been alive, no longer than a season of seasons, a handful of birthdays. Whatever you were doing 4 years past, that light was already on its way to you, crossing the dark all the while, patient and unhurried, bound for this exact night. There is a tenderness in measuring the stars not in eons, but in the gentle, familiar lengths of our own days, in finding that even the cosmos can speak, just once, in a span the heart already knows. So when you gaze toward that warm and steady ember near the southern horizon, you're not reaching across some unbridgeable abyss of time, but receiving a fairly recent word from a close companion. The nearest star is near in time as well as space, its light only lately sent, its message almost present. Of all the lights in the heavens, it is the one that feels most like a living neighbour, glimpsed not as it was in some forgotten age, but very nearly as it is. That small closeness in time is its own quiet comfort, a reminder that not everything in the vast sky is impossibly remote, that the nearest light is, in its way, almost here. There is no hurry in any of it. That light spent 4 years and more crossing the dark to arrive, and it asks nothing on its arrival, only to be received. And the faint red member of the family that sends it is, of all things, the most ordinary kind of star there is. Red dwarfs, these small cool stars, are by far the most numerous suns in the entire galaxy. The great majority of the stars in the Milky Way are not brilliant suns like our own, nor blazing giants, but small, dim, frugal red embers exactly like Proxima. They simply shine too faintly to be seen across great distances, and so they go largely unnoticed, while the rarer bright stars dominate our night sky and our imaginations. Yet if you could see every star as it truly is, the heavens would be revealed as overwhelmingly a realm of small red suns, a quiet multitude of gentle furnaces, with the bright stars scattered sparsely among them like rare jewels. The cosmos, it turns out, prefers the small and the patient. There is a lovely humility in that. The kind of star our own sun belongs to is in truth somewhat uncommon, a brighter and shorter-lived sort, while the typical citizen of the galaxy is a modest red dwarf that will outshine the ages. The nearest star to us, Proxima, is not an oddity at all, but a perfect example of the most ordinary thing in the universe. The galaxy is built mostly of these soft red lights, quietly burning, quietly enduring, and one of them happens to be our closest neighbour. The most common star in all of creation lives right next door. The numbers behind that fact are gentle and staggering at once. Of every handful of stars in the galaxy, the great majority are these small red dwarfs, perhaps 3 of every 4, a vast quiet population of faint embers spread through the dark. The bright familiar stars that fill our myths and our maps are the rare exceptions, the showy minority, while the true bulk of the Milky Way is this hushed multitude of small red suns, most of them far too dim to see, most of them never named. The galaxy is, in its quiet truth, a sea of soft red light, and our nearest neighbour is simply one drop in that endless sea. And the galaxy that holds them all is beyond counting. Our Milky Way contains something on the order of hundreds of billions of stars, so many that to count them one each second would take longer than the whole of cosmic history so far. In all that immense throng, this one small family of suns happens to lie nearest to us, a single household out of hundreds of billions, our particular neighbours in a city of stars too vast to imagine. To call Alpha Centauri our next-door neighbour is to speak of one chosen window among an uncountable multitude, and yet there it is, the closest of them all, near enough to study, near enough to dream of reaching. Our own little corner of that vast city is a notably quiet one. The sun and its nearest neighbours drift through a wide, gentle region of thinner gas, a calm pocket within the galaxy, where the stars are spread comfortably apart and the space between them is especially clear. Alpha Centauri shares this same peaceful neighbourhood with us, the two systems drifting through the same tranquil clearing in the galactic woods. It is a soft and uneventful patch of the cosmos, this home of ours, free of the crowding and turbulence found in busier quarters, a quiet place to live among the stars. We and our nearest neighbour keep house, it turns out, in one of the calmer rooms of the galaxy. And the two of us are travelling the same great road together. Our Sun and Alpha Centauri, along with all the nearby stars, sweep in an enormous slow circle around the distant heart of the galaxy, carried along on a journey so vast that a single loop takes hundreds of millions of years to complete. We are companions on that immense orbit, neighbours keeping pace as the whole wheel of the Milky Way turns. The last time our Sun and the nearest stars stood where they stand now in that galactic circuit, the Earth was a world of vast unbroken forests, and the first dinosaurs had only lately appeared. The grandest journeys of all are the ones we make without ever feeling them, swept along together through the turning galaxy. Across such spans of time, even the fixed shapes of the night must change. Because every star drifts along its own separate path, the familiar patterns we trace in the sky, the centaur and the cross and all the rest, are only temporary arrangements, slowly coming undone over tens of thousands of years. Far in the future, Alpha Centauri will have wandered to a different place in the heavens, and the constellation it now adorns will have melted into some new and unfamiliar shape. The sky our distant descendants will see is not the sky we see tonight. Yet that slow dissolving is no loss, only the gentle breathing of the cosmos, the patterns forming and softening and reforming across ages too long for any worry to follow. And the figures we know are, in truth, only pictures we ourselves have drawn. The stars of any constellation are not truly near one another. They lie at wildly different depths, some close, some impossibly far, only happening to fall along lines that our eyes link into shapes. The centaur that holds the nearest sun is a creature stitched together from stars scattered across enormous distances, bound into a single form only by human imagination. There is a tender beauty in that, in the way we have always reached up and drawn our own gentle order onto the random scatter of the heavens, finding companions and creatures and crosses in the dark, making the vast sky feel a little more like home. That impulse to find pattern and meaning in the night is among the oldest of human habits. Long before anyone knew what a star truly was, people gathered these distant lights into stories, gave them names and shapes and roles, and so turned the cold immensity overhead into something familiar and dear. The nearest sun has played its part in that long act of imagination, set as the bright foot of a wise old centaur, watched over and storied for thousands of years by the wakeful under the same patterned dark. Picture, then, what a world circling such a small red sun might experience of its day, for it would be unlike anything we know. A planet huddled close to a faint red star, as Proxima's worlds are, would likely be held fast by the star's gravity in a single fixed posture, one face turned forever toward its sun, the other turned forever away into the dark. This is called tidal locking, the same gentle grip that keeps one side of our own moon always facing the Earth. On such a world there would be no sunrise and no sunset as we know them, no turning day. One hemisphere would dwell in perpetual ruddy daylight, the other in everlasting starlit night, the two halves frozen in their separate moods. And between those two halves there would lie a most beautiful place. Around the rim of such a world, on the line dividing the endless day from the endless night, there would be a ring of eternal twilight, a band where the red sun hangs forever just at the horizon, neither rising nor setting, casting long unchanging shadows and a soft crimson glow. That ring of permanent dusk circling the whole planet might be the gentlest place on such a world, the calm border between fire and frost, bathed always in the colours of an evening that never ends. Of all the strange landscapes the galaxy might hold, few are lovelier to imagine than that quiet line of everlasting sunset, hushed and rose-coloured, wrapping a far-off world. On the bright side of such a tidally held world, the red sun would never move at all. Fixed in a single spot of the sky, it would neither rise nor set, neither climb nor sink, but simply hang there, motionless, hour upon hour, age upon age, a great ruddy lamp nailed forever to one place in the heavens. There would be no marking of time by the sun's passage, no morning or evening, only the one unchanging crimson light pouring down from its fixed perch. It is a strange stillness to imagine, a sun that has stopped in the sky and will never move again, presiding over a day that never ends. And from the night side of that world, turned forever away from its own sun, the two distant bright stars would be the chief glory of the heavens. The faraway pair, A and B, would shine there as a single dazzling point, or a close brilliant duo, far outshining every other star, casting the faintest of shadows across the dark hemisphere. A beautiful distant beacon in a sky that never sees its own sun. To stand on that far side would be to live in perpetual night, and yet never in true darkness, lit always by the cold brilliance of the two sibling suns hanging in the deep. The nearest planet's sky would hold wonders no earthly night has ever offered, so such a world would hold all three at once, one face in fixed ruddy daylight, the far face in starlit night lit only by the two distant suns, and between them a single still band of dusk dividing the two. A whole planet held motionless under its red sun, never turning, never waking, never sleeping, fixed forever in its one unchanging posture toward the light. Now widen the view once more to take in the whole shape of this nearest system, the architecture of the place. At its heart are the two bright suns, A and B, circling each other across a gap that ranges from somewhere near the span of Saturn's orbit to somewhere near the span of Pluto's, the warm and busy centre of the family. And then, far, far beyond that pair, separated by a gulf thousands of times wider than the inner dance, drifts the lonely red dwarf on its enormous slow loop. Between the bright centre and the distant outlier lies an emptiness so vast it could swallow 1,000 of our solar systems and still have room to spare. The system is mostly silence and space, with 3 small islands of light adrift within it, 2 close together and 1 far away. That vast inner emptiness is no accident, but the ordinary truth of the cosmos. Even in this, the most crowded corner of our stellar neighbourhood, the very nearest grouping of suns, the distances between the lights are immense beyond easy thought, and the space between is overwhelmingly dark and empty. Stars, even bound stars, even sibling stars, keep their great distances. The universe is, above all, a place of room, of vast gentle gulfs between small warm points, and the night sky's apparent crowdedness is only an illusion of perspective. Out there, everything is far apart, and the dark between is the largest thing of all. To picture the true scale of it, shrink the whole thing down in the mind. Imagine our sun reduced to the size of a small piece of fruit you could hold in one hand. On that scale, the Earth would be a barely visible speck circling close by, and the nearest stars, the suns of Alpha Centauri, would be other small fruits set down thousands of kilometres away, across oceans and continents, with nothing whatever in between. That is the real emptiness of space, far vaster than any picture or map can suggest. A few tiny scattered lights adrift in an ocean of dark so wide it defeats the imagination. And Alpha Centauri is the very nearest of those scattered lights. There is a profound stillness in such roominess, once the mind makes peace with it. All that emptiness is not a void to fear, but a vast openness in which the stars hang far apart, each tending its own small circle of warmth, untroubled by the rest. The universe does not press in, it opens out endlessly, giving every star its wide and peaceful berth. And you may let your own mind open into that same spaciousness now. Let your thoughts spread thin in all that room, until there is nothing crowded left in you at all, only the wide dark and the steady rhythm of your breath. It is worth marvelling too that across all that emptiness the bond between these suns still holds. Gravity is a faint force at such distances, and yet it reaches across the immense gulf between the bright pair and their faraway red companion, and keeps them bound through all the ages. A thread so fine it could not be felt, stretched across light upon light of empty dark, and still it does not break, holding the nearest family of suns together no matter how wide the dark between them grows, and the emptiness between Earth and Alpha Centauri is emptier than any word can hold. The space the light crosses to reach us is nearer to a perfect vacuum than anything ever made in a laboratory. A few stray atoms scattered through each great stretch of dark, so thin that a ray of starlight can travel for years without meeting anything at all. Out between the stars almost nothing stirs, almost nothing presses, and the light simply streams on through that immense undisturbed nothing toward your waiting eye. That emptiness is also a true and literal silence, for sound itself cannot travel out there. Sound needs air, or water, or some substance through which to ripple, and in the near vacuum between the stars there is almost nothing to carry it. The flares of Proxima, the vast wheeling of the bright suns, all of it unfolds in perfect soundlessness, a great cosmic drama played out with no noise at all. The space around the nearest stars is the most silent place imaginable, a hush so absolute that no whisper could ever cross it, a stillness deeper than any silence an ear on Earth has ever known. The cold out there is just as profound. Far from any star, the space between the suns hovers only a few degrees above the very bottom of the temperature scale, the deep chill left over from the birth of the universe itself, colder than anything that has ever touched your skin. And yet through that frigid dark, the warmth of the stars still travels, the light of Alpha Centauri crossing all those freezing trillions of kilometers to arrive, faint but unfrozen, at your eye. There is something tender in that warmth can cross such cold, that the light of a distant sun can travel through the deepest chill there is and still reach you, still touch you, still be received. And though the stars seem fixed and still in our sky, they do creep ever so slowly across the years. The nearest stars shift their positions against the more distant background by the tiniest amounts each year, so slight that the unaided eye could never catch it within a single lifetime, yet real and steady all the same. Over thousands of years these small motions add up, and the familiar shapes of the constellations slowly drift and change. Alpha Centauri, being so near, moves a little faster across our sky than most, inching along its quiet path. The heavens are not truly frozen, only patient, rearranging themselves so gradually that within any single night they seem perfectly eternal and unchanging. Let the attention come to rest, for a while, on the surface of that sun-like star, Alpha Centauri A, and on the patient fire that keeps it shining. Like our own sun, it makes its light by fusing hydrogen into helium deep in its core, pressing the lightest of all atoms together under unimaginable heat and weight until they merge and release their energy. That energy then takes an astonishingly long time to climb from the core to the surface, drifting and bouncing outward through the dense layers of the star for many thousands of years before it finally escapes as light. The sunlight of any star is ancient by the time it leaves, energy born in the heart of the star long ago and only slowly working its way free. So the light that warms a world beneath Alpha Centauri A, or the light that we might one day catch from it through a telescope, began as a flash of fusion in the star's deep centre, an age before it ever reached the surface. The star is patient in everything it does, slow to make its light, slow to release it, slow to live out its long, bright life. There is no haste in a star. It simply burns steadily for billions of years, pouring out warmth at a pace too vast and too even for any sudden change. To rest beneath such a light, or even to imagine resting beneath it, is to borrow a little of that immense and unhurried calm. The way a star makes its light from the lightest of all things is a quiet marvel. Deep in the core, under crushing weight and searing heat, the simplest atoms, the bare nuclei of hydrogen, are pressed together step by patient step until they fuse into helium, and in that joining a tiny sliver of matter is transformed directly into pure energy. It happens countless times each instant, this gentle alchemy, turning a little substance into a great deal of light. A star is, in the end, a place where the smallest pieces of the universe are quietly knit into warmth, the most basic stuff of all becoming the glow that fills a sky. There is a deep simplicity at the heart of every sun, including the nearest ones, a slow and steady weaving of light out of almost nothing, and the amount of itself a star spends to shine is astonishing in its restraint. To pour out all its enormous light, a sun like Alpha Centauri A converts only a small portion of its vast substance each moment, sipping at its own great body across the billions of years, so slowly that it can keep burning for ages beyond counting before its fuel runs low. The star is rich beyond measure and spends with the gentlest hand, and that frugal generosity is why it can shine so steadily for so long. There is no extravagance in a sun, only a vast patience, a giving that goes on and on without ever seeming to diminish the giver. Now let the mind drift to the gentler companion, the orange star, and to the special quality of its colour. Alpha Centauri B, being cooler than the sun, casts a light shaded faintly toward amber and gold, the warm hue of a lower fire. A world beneath it would know skies tinted just a little differently than ours, dawns and dusks soaked in deeper gold, a noon that leaned ever so slightly toward the honeyed light we only know at the edges of our own days. Cooler stars give warmer coloured light, a quiet paradox of the heavens, and the orange suns are among the most softly beautiful of all, pouring their amber glow across whatever worlds they hold. Imagine living always within that gentle golden light, where every hour wears the soft colour of late afternoon. There would be a perpetual warmth to the look of things, a mellow honeyed cast over land and cloud and water, the whole world dipped in the colours of a long, slow evening. It is a kindly sort of light to picture, easy on the eye, restful by nature, the very colour the mind reaches for when it wants to feel calm. Let that warm amber glow fill the space behind your eyes now, soft and low and golden, the light of a sun made for resting beneath. There is reason to think such orange suns may be among the gentlest hosts in all the galaxy, cooler and calmer than stars like our own, yet far brighter and steadier than the small red dwarfs. These middle stars burn with a mild, even temper for an immensely long time, longer than suns like ours can manage, without the fierce flares of their smaller cousins. Some who study these things consider stars of just this orange kind to be especially kindly places, offering a soft, lasting, well-tempered light across the ages. And one such gentle star, Alpha Centauri B, sits right beside us, the very nearest of its calm and patient breed. That the nearest system holds both a sun like our own and one of these gentle orange stars is a quiet stroke of fortune. Between the familiar yellow light of the foremost sun and the mild amber glow of its companion, the closest stellar family offers two of the warmest, most temperate sorts of starlight known, set side by side. It is as though the nearest doorway to the galaxy were furnished with the kindest of lamps, a pairing of gentle suns resting low in the southern dark. Of all the systems the heavens might have placed closest to us, we have been given one lit by such soft and steady fires. There is a deeper lesson hidden in these three different suns, in the yellow and the orange and the red gathered in one small family. They show, all together in a single bound system, how varied the stars can be, how a near twin of our sun, and a gentler orange star and a tiny red ember can all belong to the same household, born from the same cloud, drifting through the same dark. The galaxy is full of such variety, and here it is, sampled in miniature, right next door. 3 kinds of star, 3 colours of light, 3 different paces of life, all held together by the patient hand of gravity. The nearest system to us is, in its way, a small museum of what suns can be. The 2 bright suns are likely a touch further along in life than our own. Though their exact age is gently uncertain, the best reckonings place them 1 billion or 2 years older than the Sun, a little more weathered, a little nearer the later chapters of their long stories. They are in a sense our elders among the nearby stars, suns that were already shining when our own was still young. There is something quietly reassuring in that, in the thought that the nearest stars are seasoned and settled, far along their steady course, burning with the calm assurance of things that have endured a very long while and have a great while yet to go. In the deep future, those 2 bright suns will not stay as they are. Like our own Sun, each will one day exhaust the hydrogen in its core and slowly swell into a great red giant, ballooning outward, glowing cooler and vaster before shedding its outer layers and settling at last into a small dense ember of a dead star. That fate lies billions of years off, further ahead than the whole age of the Earth behind us, but it is written into them all the same long arc our own Sun will someday follow. The nearest suns are mortal, as all stars are, living out their immense slow lives and bound in the fullness of time for a quiet and gradual ending. Only the little red dwarf will far outlast them, burning on long after its bright siblings have faded. Yet none of that distant change need trouble this night, for on the scale of a human life these stars are the very picture of constancy. They have shone without a flicker through all of history, and they will shine on steady and unchanged through every night anyone now living will ever know and countless nights beyond. The slow drama of their birth and death plays out across spans so vast that, to a single lifetime, the nearest suns are simply fixed and faithful, always there, always the same, holding their ancient places in the dark while the small world of a single day shifts and turns beneath them, and one steady force keeps all 3 of them in their places. The nearest stars ask nothing and change nothing. They only shine, as they have for billions of years and will for billions more, and what holds them so faithfully to one another is the same plain force that shapes every falling and circling thing. That force is gravity, the same one that holds you to your bed this moment. It is gravity that keeps the 2 bright suns circling each other. Gravity that holds the distant red dwarf, however faintly, within the same family. Gravity that has bound these 3 together through billions of years and will bind them for billions more. The very same force that draws an apple to the ground, that gives your body its weight against the mattress, reaches across light years to hold whole suns in their long embrace, cradling you and cradling the stars in the very same instant. Feel that for a moment, the constant pull that holds you down into rest. It is the same force that binds the nearest stars. Let it settle you deeper. Let your limbs grow heavy with it, your body sinking into the surface beneath, held by the very gravity that holds the suns. There is nothing to do against it. There is only the letting go, the easy yielding, the descent into stillness. The bond between the 2 bright suns is so well understood that their dance can be charted far into the future. For more than 3 centuries, astronomers have watched the pair circle one another, noting their positions across generations of observers until the shape of their orbit was mapped with great care. From that long record, we can now say with confidence where the 2 suns will stand 100 years from now, or 1,000, tracing the curve of their embrace far ahead in time. The motion of the nearest stars is no mystery but a known clockwork, turning exactly as it should, faithful to the same simple law that governs a falling leaf. That such a bond should hold so steadily for billions of years is a wonder of its own. Through all the long ages, as worlds formed and life arose on a distant blue planet, the 2 bright suns have kept circling one another without fail, never parting, never breaking their long agreement. Gravity asks for no maintenance and grants no rest. It simply holds, endlessly, binding the suns as surely now as in the beginning, the same dependable force at work since before the Earth was born. Turn the imagination now to what it might be like to actually stand within that system, on a world beneath the 2 bright suns, and to look up at a sky with not one sun but two. From a planet circling Alpha Centauri A, the second star, B, would not be a distant point but a brilliant nearby light, far brighter than any star in our own night, though much smaller than the world's own sun. By day it might cast a second set of faint shadows. By night it might shine like a tiny dazzling moon of pure white gold light, never quite letting the dark grow fully black. The sky of such a world would hold two suns of different colours, and the play of their two lights across the land would be a thing no earthly evening has ever known. Picture the shadows on such a world then, doubled and crossed, soft-edged and strange, falling in two directions at once beneath two suns. Picture a twilight where one sun has set and the other still glows, a long lingering brightness with no true night. Picture the gentle confusion of light that such a place would hold, beautiful and disorienting and utterly unlike home. It is a scene worth carrying softly into sleep, a far-off world washed in the mingled glow of two warm suns, quiet and golden and impossibly serene. The rhythm of days and seasons on such a world would be a richer, stranger music than ours. With two suns moving through its sky on their own separate timings, the brightening and dimming of the day would weave together in long, intricate patterns, sometimes both suns aloft and flooding the world with double light, sometimes only one, sometimes a soft glow as one set while the other still hung low. There would be no simple noon, no plain and single sunset, but a slow braided dance of two lights, shifting across the long turning of the years. To live there would be to know a sky forever composing new arrangements of light, gentle and complex and never quite the same twice. For a long while, astronomers wondered whether worlds could even survive in a system of two close suns, whether the competing pulls would forbid any planet a stable home. Yet the closest planets to us, circling the little red companion, show that worlds can indeed endure within such a family, finding quiet orbits that hold steady through the ages. The presence of planets here, in the very nearest multiple star system, is itself a gentle reassurance, a sign that the universe makes room for worlds even amid the crowded gravity of several suns. Where there are stars, it seems, there may very well be worlds, even in places we once thought too unsettled to allow them. Stand now upon an imagined world of the orange star instead, and the sky would shift its character again. There the gentle amber sun would be your own, filling the day with its mellow honeyed light, while the brighter yellow star, A, would ride the heavens as a fierce and brilliant companion, sometimes near, sometimes far, always far outshining every true star of the night. Your days would be ruled by the soft orange glow, your nights sometimes silvered by the dazzling presence of the second sun, the play of two lights forever shaping the look of the land. To live beneath the orange star would be to know a world of warm amber afternoons watched over by a distant brilliant second sun, a sky unlike any our single sun has ever made. There would be seasons within that pairing too subtle for us to imagine, slow swings as the brilliant second sun drew near across its long orbit and then withdrew. When the two suns stood on the same side of the sky, the world might know a season of double brightness, the nights barely darkening. When they stood apart, the deep nights would return, lit only by the orange sun's setting and the faraway stars. Across the long decades of the sun's dance, the very texture of darkness on such a world would rise and fall, a grand slow rhythm of brighter years and dimmer ones. The nearest stars, were any world to circle them, would gift it a calendar far stranger and richer than our own. Picture the two suns of such a world sinking together toward its horizon, the yellow and the orange settling low side by side, their mingled glow deepening from gold to amber to rose, then to a long blue dusk that lingers as one star slips under, while the other still burns above. On a world of two suns, even the close of day would come not once but twice, in colours layered one upon another, an evening richer than any single sun could paint. The discovery that this single light was truly two suns came more than 3 centuries ago. An astronomer peering through one of the early telescopes noticed that the brilliant point of Alpha Centauri resolved into a close pair, 2 stars where the eye had always seen one, and so it became one of the first double stars ever recognised in the southern sky. For all the ages that people had named and navigated by this light, no one had known it was a partnership until the lens revealed it. Each new instrument has peeled back another layer of the truth, first showing the 2 bright suns, then, centuries later, the faint red companion hiding far out in the dark. The nearest star has slowly unfolded its secrets, one careful look at a time. The whole family weighed together is a modest gathering. The 2 bright suns and their tiny red companion add up to only about twice the mass of our own single sun, the great bulk of it carried by the foremost yellow star and its orange partner, with the little dwarf contributing barely a fraction. So the nearest system is not some heavyweight of the heavens, but a light and graceful thing, 3 small suns whose combined substance only gently exceeds our own lone star. There is an elegance in that modesty, in the way the closest stars are not giants hoarding vast weight, but a slender, balanced trio, leaning together with a lightness that belies the eons of their bond. The faint red dwarf carries a quiet third name as well, beyond Proxima. In the orderly catalogues of astronomers, the bright pair are labelled Alpha Centauri A and B, and the little outlier, being the third member found, took the next letter and became Alpha Centauri C. So Proxima is, by another name, simply the C of the family, the third son of the household, the youngest discovered of the 3. There is something homely in that lettering, A and B and C, as though the nearest stars were siblings listed in order in a family record. 2 bright elders and 1 small dim third, all sharing a single name, all bound into one slow journey through the night. Consider how very small our entire solar neighbourhood is against the vastness it sits within. Alpha Centauri, the nearest system of all, lies more than 4 light-years off, and that is merely the first step into a galaxy that stretches 100,000 light-years across. If our Sun and Alpha Centauri were 2 grains of sand, they would be set apart by many miles of empty floor, and the whole Milky Way would be a thing too large to walk across in a lifetime. The closeness of Alpha Centauri is closeness only by the most generous cosmic measure. In human terms, it is a distance beyond all reaching. And yet it is the nearest there is, the very edge of our own small clearing in the immense dark forest of stars. Because it is the nearest, this system has always been the first that human imagination reaches toward. Ever since people began to dream of other worlds and other suns, Alpha Centauri has been the favoured destination of those dreams, the natural first stop in countless stories of starfarers and distant colonies. It is the place our imaginations go when they leave the sun behind, the closest shore of the great dark sea, written into our tales of the future again and again precisely because it is the nearest real elsewhere there is. The closest star has long doubled as the closest dream, a fixed point where hope and possibility quietly gather, and in a small, true way, we have already reached toward it. For about a century now, the Earth has been quietly leaking its radio whispers into space, the faint signals of our broadcasts spreading outward in all directions at the speed of light. That expanding bubble of human sound has by now washed over Alpha Centauri and passed beyond it, so that the oldest of those signals have already crossed the nearest star and travelled on into the further dark. In a sense, the faintest echo of human presence has been there and gone, a thin ripple of voices that long ago reached the closest threshold and continued on its way. The nearest star has already been touched, not by any ship but by a whisper. We have also sent more deliberate greetings outward, small messages meant to outlast us. Aboard the most distant of our spacecraft ride engraved records bearing sounds and images of Earth, music and greetings and the murmur of our world, drifting now through interstellar space on a journey of countless thousands of years. None of them are aimed at Alpha Centauri, and none will arrive there, but they carry the same quiet impulse, the wish to reach across the dark, to say to whatever might be out there that we were here, that we wondered, that we cared to send word. the nearest star stands as the symbol of all that reaching, the closest face of the great beyond toward which we have always longed to speak. And against the long measures of that vastness, the little red star at the edge of the nearest family has a future stranger than almost anything in the sky. Where the bright pair will run their course in a few more billion years, this faint coal is only at the very start of a life that will stretch on for trillions, its slow fire barely touched by the passing of whole cosmic ages. Long after our own sun has swelled and reddened and finally faded to a dim cinder, Proxima will still be shining, almost unchanged, its frugal fire barely diminished. And in the unimaginable distance of time, as the very last of its hydrogen is at last consumed, this red star is expected to grow not redder and larger as our sun will, but hotter and bluer for a while, shrinking into a small, intensely blue star, before finally cooling into darkness over ages beyond all counting. It is a different ending than our sun's, a long brightening rather than a swelling collapse, the star running its course across spans of time that dwarf the present age of everything. To grasp how long that little star will endure, set its lifespan beside the whole age of the cosmos so far, the entire history of the universe, from its fiery birth to this very night, is but a small fraction of the time that Proxima still is left to burn. If all the ages that have already passed were a single hour, the red dwarf's remaining life would stretch on for days and days beyond it. We stand at the merest beginning of the story of such stars, in the first faint light of a cosmic morning that will last almost beyond imagining. The nearest star is among the youngest of the long-lived, with nearly its whole vast life still ahead. In the deepest future of all, stars like Proxima may be the last warmth the universe knows. When the bright suns have long since died and no new stars are being born, when the galaxies have faded and the great cosmic blaze has dimmed away, these small red dwarfs will go on glowing, frugal and faithful, the final lamps in a darkening cosmos. The kind of star that sits nearest to us tonight is the kind that will keep its vigil longest, holding a little warmth against the encroaching dark long after almost everything else has gone still. Set that endurance against the brief flicker of a single human night, and it grows almost tender. The little red star next door will outlast not only our sun, but very nearly the entire bright era of the universe, and yet tonight it is simply there, a faint coal over the southern horizon, no different to the eye than it was 1,000 years ago, or will be 1,000 hence. The most enduring thing in all of creation is also, just now, one of the quietest neighbours a person could have. There is a deep peace in knowing that somewhere just beyond our sun, such a light exists, in no hurry, certain to outlast every passing trouble, every age, nearly every star. It will be shining when everyone now alive is long gone, shining when the earth itself has changed beyond knowing, shining still in an emptied universe that has forgotten how to make new suns. That faithful little coal asks nothing and endures everything, keeping its steady place across all those light years at the edge of the southern night. Now let the mind hold the whole of it together, all three suns at once leaning close in their distant family. The yellow sun, much like our own, pouring out its familiar golden light. The gentler orange star beside it, warm with amber. The tiny red ember far out in the dark, patient and enduring and ringed with its small worlds. Three suns bound by gravity drifting together through the galaxy on a single slow journey, the nearest of all such families to the small blue world where you lie resting now. They have been there all your life, and all the lives before yours, and they will be there long after, faithful points of light just over the edge of the southern sky. You do not need to remember which sun is which, or how far, or how bright. You do not need to carry away a single fact from all of this. Let it settle, or let it drift, as it pleases. The stars do not require your attention to go on shining. They will keep their slow appointments, and turn their slow orbits, and pour out their ancient light, whether you watch or sleep. And tonight, you may sleep. The nearest suns are keeping watch, and there is one last wonder to rest upon, the quietest and perhaps the deepest of them all. For all that separates us from Alpha Centauri, all those trillions of kilometers of cold and empty space, there is something profound that we share with it, something woven into the very substance of those distant stars and of your own resting body alike. The atoms that make up Alpha Centauri's suns and the atoms that make up your blood and bone and breath were forged in the same way, in the hearts of stars and in the great events that scattered their elements across space. The iron in your veins, the calcium in your bones, the carbon at the core of every living cell within you were all cooked long ago inside ancient stars and flung out into the dark to gather again into new worlds and new life. And the very same kind of fire that built those atoms still burns, this very night, in the nearest suns over the southern horizon. So you and Alpha Centauri are not truly strangers, not wholly apart. You're made of the same stuff, you and that distant family of suns, kindled in the same furnaces, born of the same long cosmic story of stars living and dying and giving rise to everything that follows. When you look toward that warm point low in the sky, you're looking at a cousin, a relative across the gulf, another expression of the same ancient stardust that also became you. The nearest stars are, in the most literal sense, akin to you, sharing your origin, sharing your elements, sharing the long inheritance of the cosmos. You're a small warm gathering of starlight, lying here in the dark, gazing peacefully at the others. Let that be the thought you carry down into sleep, soft and whole and wordless. You're not separate from the stars. You are of them, and they are of you, and the same gentle fire that lights the nearest suns also flickers quietly in the warmth of your own resting heart. There is nothing more to know tonight. There is only the deep belonging, the quiet kinship, the soft dark, and rest. The journey is finished now, the whole long sweep of it, from the warm point low in the southern sky to the tiny ember on the family's far edge, and you have come gently to its end. There is nothing left to reach for, nothing left to picture, nothing left to do. And if you are still here, still drifting in the soft dark with your eyes long closed, another quiet journey is already waiting for you nearby on the screen, ready whenever you might wish it, or never at all, asking nothing, only there, like a faint light left burning in a far window. Hold on to none of it. The numbers, the names, the distances, the suns, let them all slip easily away. None of it was ever yours to keep. It was only ever meant to drift through you, soft as starlight, and to leave you calm and quiet and ready for rest. Whatever stayed, stayed of its own accord. Whatever went, went freely. There is nothing here to carry into your dreams but the gentlest sense of wonder, and that too will soften and fade as you sink. Let the breath grow slow now. Let it grow deep and easy and long. Feel the weight of your own body, heavy and warm, settling down into the soft surface beneath you, held by the same patient gravity that holds the distant suns. There is nowhere to be. There is nothing to keep. There is only this quiet and this warmth and the slow tide of your breathing. The stars are far away, and they are kind, and they let you be. They will turn through the dark while you sleep, faithful and unhurried, keeping their slow and ancient watch over the small blue world where you rest. You may let them go now. You may let everything go. Your thoughts grow soft, your limbs grow heavy. The dark is gentle and close and safe. Rest now beneath the nearest stars, and now 101 wonders are resting with you. Sleep now. Good night.